Warning! Quantum mechanics is really, really complicated, and the guys who came up with it have gone on record saying that no one really understands it. Fight! Cotton Feynman! So, what is quantum mechanics? It's the language that atoms and subatomic particles speak to one another with. It's different than the language the moon speaks to the Earth. That's gravity, and it doesn't matter at this scale. In the quantum world, particles aren't always particles. Most of the time, they can be better described as waves. Schrödinger is a name you might have heard, and he once represented his cat as a wave function, and this is what it looks like. The Greek letter psi represents what is referred to as a wave function, partially representing a live cat and partially representing a dead cat. The same thing works with numbers. This is called a superposition of states, which sometimes represents one thing and sometimes represents something else. So, what is quantum computing? Well, what is computing? Classical computing and classical information rely on bits, which are always either a 1 or a 0. 8 bits in a row is called a byte, and a billion of those is called a gigabyte, which is about as much information as you need to copy a DVD of a long movie. Bits are a physical thing called transistors. By applying voltage to a transistor, you can turn it on, representing a 1. Take the voltage away, and you get a 0. So here's your computer, with a billion or 2 transistors, and here's you with a question. You ask your computer, it answers, and you keep living your life carefree. But as you get older, you start asking more difficult questions, about math, I guess. And for a while, your computer can handle it. But then you want to know the prime factors of a 57-digit number, and your computer's like, come on man, I don't know how to do that. I'm going to catch on fire like this one. Well, now you can't go on living the way you once did. You need a new kind of computer. Let's try a quantum computer, you say, and you go buy one for like $1 million, and sure enough, it gives you some prime factors. But how did it do it? What the heck is a qubit, anyway? Is it a transistor? No. Qubits are all kinds of small things right now. Science is still trying to figure out what the new transistor will be. Josephson junctions are superconducting loops that take advantage of quantum tunneling. Quantum dots are a lot smaller and essentially act like artificial atoms where there's a single electron you call a qubit, and the electron's spin, either up or down, is the 1 or the 0. Nuclear magnetic resonance qubits don't work as well because they don't entangle. Say, what's entanglement, you ask? Why, it's when 2 qubits just can't stop gabbing with one another. They talk no matter how far apart they are, and their relationship becomes exponentially harder to describe. So let's say we have 300 entangled qubits all talking. That's 2 to the 300th classical bits of information, which is a bigger number than the number of particles in the known universe. But they have to stay entangled to keep all that information, which isn't easy. Here's 8 qubits, all entangled and whatnot, so that means we're up to 256 bits of normal Bill Gates information, and you're probably saying, hey, why aren't we using this all the time? Which is a pretty good question, except wait a minute, we need to measure this thing, and as soon as we do that, all the electrons decide whether to spin up or down, and you really become zeros and ones, and if you know how to read binary, you know they just represent the number 189. Measurement appears to be a problem, so enter this guy, Peter Ladies Man Shore. Hey, I'm Peter Shore, and I figured out a sweet-ass algorithm that lets you factor 57-digit numbers, which is totally super important. Other people have also created quantum algorithms, which also are cool, but aren't as cool as mine. Yeah, whatever, Pete. I'm sure it's cool. Excuse me, do you have any idea how hard it is to understand quantum entanglement well enough to use it to accomplish any sort of real-world task? You can sort of think of quantum entanglement of qubits like young people at a rave. They're all tied together by some kind of hippie terrorist bond that allows the group as a whole to experience all kinds of things. Physical exertion mixes with a cocktail of designer drugs and painfully loud music to draw hundreds of thousands of individuals into a highly synchronized dance party. As a group, they are able to express profound ideas of chaos, unification, love, and rage, which is all superimposed in the meaning of one hell of a party. But ask any one of the attendants a question, and you will receive a one-word answer.
Heard of Shorty Jizzle and the Plumber Cracks?
Yep.
Did you know that Coachella is actually the American Indian word for dumb white guy?
Really?
And sometimes that answer is wrong. Remember these guys? Well, it turns out that they have a really hard time hearing one another because the quantum world is so crowded all the time. If an electron is trying to talk to just one other atom, it's impossible because all the chaotic photons and neutrinos and other jerks of the quantum world are always whizzing and bumping around into everybody and knocking them down, and it's just a total mess, and it's so frustrating. Hi, I'm Jordy Rose, the founder of D-Wave, and this is one of the craziest looking things I could possibly have stood next to, eh? Me and my friends know all about shielding quantum computers from the environment, and as a result, we have a total monopoly on the quantum computing market. We use Josephson junctions as qubits, meaning that depending on which arrow, the red or the blue, we measure spinning around the ring, that dictates whether the qubits reads a 1 or a 0. Pretty cool, right? Yeah, I'm very pleased with myself. In summary, pause this video and review the points as you wish. Thank you for watching.